Imagine standing in front of a machine so enormous that it towers over a 4-story building. A machine powerful enough to cut through solid granite, strong enough to drill beneath entire cities, and capable of carving tunnels through mountains that once seemed impossible to cross. It doesn't use explosions. It doesn't rely on giant drills like you'd expect. Instead, it slowly, relentlessly eats its way through rock. This is the tunnel boring machine, the engineering giant that's quietly changing the world beneath our feet. But how can a single machine dig through one of nature's toughest obstacles? Let's find out. For thousands of years, mountains were among humanity's greatest barriers. They separated countries, delayed trade, made transportation dangerous, and sometimes turned a journey of just a few miles into a trip lasting several days. The obvious solution was simple: go through the mountain. But that was much easier said than done. For centuries, workers relied on hammers, chisels, and later, dynamite. It was slow, expensive, dangerous, and often deadly. Entire tunnel projects could take decades to finish. Engineers knew there had to be a better way, so they built a machine unlike anything the world had ever seen. At first glance, it looks like something from science fiction. A tunnel boring machine, or TBM, is one of the largest and most advanced machines ever built. Some are longer than 2 football fields. Some weigh over 4,000 tons. And their cutting heads can be more than 17 meters, or 56 feet, in diameter. Each one is custom built for a specific project, because every mountain, every rock, every tunnel is different. Building one can take years, and depending on its size and complexity, it can cost hundreds of millions of dollars. But once it begins moving, very little can stop it. The secret lies in the massive rotating cutter head at the front. Instead of sharp blades, it uses dozens of extremely hard disc cutters made from specially engineered steel and alloys. As the head slowly rotates, these cutters press against the rock with thousands of tons of force. Rather than slicing the rock, they crush it. Tiny cracks begin to spread. Those cracks grow larger until massive chunks suddenly break away. It's surprisingly efficient. Even some of the hardest rock on Earth eventually gives in. Behind the cutter head, giant hydraulic cylinders push the entire machine forward, just a few inches at a time. Slow, steady, relentless. 24 hours a day, sometimes for years without stopping. Digging the tunnel is only half the job. Every minute, the machine creates tons of broken rock. So what happens to all of it? Inside the TBM, powerful conveyor belts continuously carry the crushed rock away from the cutting head. The debris travels through the machine, then out of the tunnel, where it's loaded onto trucks or trains. Some projects remove millions of tons of rock, enough to fill entire stadiums. And while all that material is leaving the tunnel, construction is already happening behind the machine. Here's the incredible part. The TBM doesn't just dig, it also builds. Right behind the cutter head, massive robotic systems place giant concrete segments into position. These pieces lock together to form a perfectly shaped tunnel ring. Within minutes, the freshly dug tunnel already has solid walls. It's like watching a giant mechanical worm dig a hole, while building its own shell behind it. This allows engineers to safely construct tunnels beneath busy cities, under rivers, and even deep below mountains, without everything collapsing above them. Of course, mountains don't make things easy. One moment the machine may be cutting through solid granite. The next, it could hit soft clay, underground rivers, or unexpected fault lines. Water can suddenly rush into the tunnel. Extreme pressure can damage equipment. Temperatures deep underground can become dangerously high. And if just one critical component fails, replacing it may require weeks of work. Sometimes engineers must enter the cutter head itself, inside a pressurized chamber, to replace worn cutters. One mistake could be fatal. Every meter forward is earned. Today, tunnel boring machines have helped create some of the world's greatest engineering projects. Railways through the Alps, massive subway systems beneath cities, high-speed rail tunnels, road tunnels beneath oceans, and underground infrastructure that millions of people use every single day, without ever realizing what lies behind the concrete walls. Some of these tunnels stretch for dozens of miles. Projects once considered impossible are now routine. As cities continue to grow, the future may not be above us, but below us. Engineers are already designing larger, smarter, and even more autonomous tunnel boring machines. Machines capable of digging faster, safer, and deeper than ever before. One day, they may even help build tunnels on the moon or beneath the surface of Mars. The next time you drive through a mountain or ride a subway beneath a city, remember, hidden behind those smooth concrete walls is one of the greatest engineering inventions humanity has ever created. A machine that doesn't simply drill through mountains, it rewrites what's possible. Thanks for watching.